Let's talk about intercepts of graphical functions. And most of you, if you've talked or learned about intercepts before with graphs, you probably usually were asked to find the X and Y intercepts. So once again, we have this issue with Y and f of X being interchangeable. Now here's a case, even though we're going to look at graphical functions, I just don't, in the world of math, hear people too much talking about finding the f of X intercept. Even if your graph you're looking at, the vertical axis is like the function, sometimes they just still like to think of it as the y-intercept. But hopefully by now, you're used to going back and forth between f of X and Y, and it doesn't really faze you. Let's quickly just, wow, that's a pretty bad. Let's quickly, once again, just highlight what exactly intercepts are, and then them explain how, once again, in the world of math, sometimes they give the same answer in two different forms and how they both make sense, but just explain what's going on there. So anyways, how about here's a line on a graph and say that's 6, and we got -4. Intercepts are when the function or the graph crosses, or sometimes it just touches either axis. Intercept, sometimes we think of it's pretty close word with intersect. So here, this graph is now crossing the y-axis. So that point we call the y-intercept. And then here, the graph crosses the x-axis. So we call that point the x-intercept. So if you were given this graph and you were asked to find the intercepts, sort of makes sense. So the intercept is actually a point here. It's the point at which this graph crosses this x-axis. So the x-intercept, you would say, is -4, 0. That's that point. And the y-intercept is this point right here. It's where this graph once again crosses the y-axis, 0, 6. So that would be the two intercepts. Now here's what happens a lot. It's pretty common, and it's not right or wrong, it just happens. These are the intercepts as ordered pairs, right? Which is normally when we try and designate a point on the graph, we give the ordered pair. But here's what happens sometimes. Sometimes someone will be given this graph and they'll be asked to find the intercepts. And they'll say the x-intercept equals -4 and the y-intercept equals 6. And then someone says, wait a second. If we're trying to describe the intercepts, these intercepts are points on this graph, and the way you describe points on the graph is by giving both the x and the y. So how can you describe this x-intercept by just saying it's -4, and how can you describe the y-intercept by just saying it's 6? Very good question, and it's pretty straightforward to answer, because anytime you're looking at an x-intercept on a graph, what is the value of y going to be for every x-intercept? Or it's just for fun, what if I just draw a few other sort of graphs on this same xy axis? So here's an x-intercept, here's an x-intercept. So actually I've got 3 x-intercepts sort of drawn in this graph. What's the value of y for all 3 of these x-intercepts? Well, the value of y is 0 for all 3 of these. Matter of fact, anytime you have an x-intercept, the value of y will always be 0, because that's by definition what's going on. Whenever you intersect the x-axis is basically y equals 0. So when you describe an x-intercept, the only interesting part of it is the value of x. The value of y is always going to be 0. So sometimes in the math world, instead of writing the ordered pair and always having to write 0 for y, they're just like, why do we keep having to write 0 for y? We all know what the value of y is. Let's just give the important part, and they just say the x-intercept is -4. And the same way with the y-intercept, if you look at every y-intercept you can look at, what's the value of x always going to be at a y-intercept? It's going to be 0. So instead of every time you write a y-intercept having to put a 0 here for x and then put your number for the y, they're just like, why do we keep writing zeros? How about we just write down the important part? The important part is going to be the y value. So in other words, if you look up here, what's the y-intercept? The y-intercept is 6. Because you know x has to be 0. Just sometimes they will, if certain textbooks and maybe certain, if you're ever doing some math online, they may want the answers in ordered pair, or they may just want the number. Hopefully they will tell you what they prefer. So if you have to type it in, especially online, you can put it in the form they want. But for me, for an exam or a quiz, either one of these is fine. All right. So I printed out a bunch of graphs. Now it's funny how, for right now, we're just going to look at determining the intercepts when we're looking at graphs of functions. Obviously, when we look at functions, that's an equation, we will also have to determine the x and y intercepts, and that's something to do mathematically. But for now, I'm just wanting you all to get a good feel when you look at the graph of a function, what the intercepts are. Let's just go through these. This ought to go pretty fast. A couple of interesting things to look at. So for instance, here's the graph of a parabola. Just, if you want to know, here's the function. I mean, it's pretty easy. I could just take this equation and mathematically calculate the x and y intercepts, and we'll do that in this class. But for now, I'm just wanting us to get a good feel for looking at graphs of functions. So here it is. So if I'm asked to find the intercepts, I'm looking at where does this graph cross or touch either the x or y axis. It's interesting. If I say, what's the x-intercept? You look, the x-axis, this graph actually never touches or crosses the x-axis. So it means there actually are no x-intercepts. However, here, you can see the graph crosses the y-axis. And if we look at the scale here, it looks like this is at 2. So for me, just to keep it simple, we'll say the y-intercept equals 2. Straightforward. Here's something interesting. Because the kind of function we have here, looks like we're crossing the x-axis here. So here's an x-intercept. Maybe I'll circle it. Then we come, what's interesting is here, we're actually crossing the x-intercept and crossing the we're crossing the x-axis and we're crossing the y-axis. Actually, it's going through the origin. So we're crossing both the x and the y-axis at the same point. Then you keep going, and it looks like here you have another x-intercept. So it looks like to me, we actually have 3 x-intercepts, 3 different values of x where the graph crosses the x-axis, and 1 y-intercept. So we could just say, well, we just list them. This looks like -2 x of this intercept here. The value of x is 0. The value of x here is 1. So there's the 3 x-intercepts. Y-intercept, we've only got 1 y-intercept, it's here. What's the value of y? It's 0. Not too difficult, hopefully. It's like another parabola. So here's the origin, just to get your orientation. So it looks like we have an intercept here, across the x-axis here, we cross the y-axis, another x-intercept. So we were asked, what are the x-intercepts? Just for fun, just because I can, I'm going to write these in ordered pairs, just to sort of have some variety. So this point here, x-intercept is -2, 0. This one here is 3, 0. Y-intercept looks like it's right here. 0, -6. All right, so once you get the hang of these, not real difficult. But now here's what can happen, especially when you're trying to find intercepts when you're just looking at the graph of a function. Obviously, I have some intercepts here. It's an x-intercept, it's a y-intercept, x-intercept. Looks like 3 x-intercepts and 1 y-intercept. So I'm asked, what are the intercepts? Here's what's tricky. If I look at this intercept right here, when you're looking at a graph, it's not like you can just estimate or guess on the answer. When you're trying to give information from a graph, you need to be able to be very precise. I say that to explain this. If I look at this intercept, it's pretty clear we can see that the graph, the line crosses the x-axis. This is 1 here. So that's dead nuts on this line here. So that's got to be 1/2. So I could say but what if I go over here and now I need to give this x-intercept? Well, look at the line crosses the x-axis in between. You know, if this is -1, this is -3/2. So it's somewhere between -3/2 and -2 that my line crosses the x-axis. But just by looking at this, I'm not able to, it's not clear at all what this actual value of x is here. So honestly, in this case, and normally they wouldn't do this, they wouldn't give you a graph like this and then ask you to give the x-intercepts because you can't really tell here. All you can do is make a guess. Oftentimes with graphs, it's very clear, like this even up here for this y-intercept. It's very clear that this graph crosses exactly at this point 0, 0, 2. So the y-intercept, I'm very confident I can say it's 2. But these two x-intercepts here on either end, I have no idea exactly what the value of x is where this graph crosses. So really, it would be hard to answer this question. Now, this graph here, here's the actual. Now you could, although honestly, even looking at this, you could try and solve it mathematically to find the intercepts, but even that would not necessarily be an easy problem. So I threw this one in just to point out that everything's not always cut and dried. I mean, we have 3 x-intercepts. If someone says, what are the values of the x-intercepts? I'm not sure. And it may take a fair amount of work to figure it out. It's sort of crazy, but that's the way math can be sometimes. Here's something else. All right, we've seen this kind of graph before. Here's your origin. We're asked to find the x and y intercepts for this function. So you know, this is a kind of function where the graph has 2 parts to it. So I'm looking for wherever the function crosses the x to y axis. So here's my y-axis, here's the x-axis. Now you notice, we've talked about this before, I didn't draw them on here, but actually looks like there's probably an asymptote here at y equals 0. So this graph never actually really touches, never crosses the x-axis here, and it never crosses the x-axis here. We do cross the y-axis right there, but once again, I have no idea how to estimate what the y-intercept is because it's not on one of my cross points. So there is a y-intercept, but really what I wanted to show this to you is that there are no x-intercepts. Sometimes that happens. What's next? Sort of the one we just looked at. If I look at this one, now here's one where, so here's the y-axis, here's the x-axis. Here's 2 pieces to this graph, 2 parts. Here's an intercept, here's an intercept. It's funny how this other part of the graph never does cross either the x or the y-axis. This one's pretty straightforward. So I know without any doubt, I have an x-intercept of 1. Now this one, so it's in between their cross marks. Sometimes, I mean, this looks like, man, it's right in the middle of these. So if this is 0 here and this is 1, 1, 2, 1, 2, 3, 4. This is exactly halfway in the middle. I would have a pretty good guess of saying the y-intercept is probably 1/2. Now the way to check it absolutely is you would look at the actual equation. And for this one, it actually is 1/2. It looked like it, but you never know for sure when you're just eyeballing it. But this one I thought was pretty good. All right, here's one of these sort of sideways parabolas. Looking for the intercepts. So here's my origin down here. looks like it crosses the x-axis right here. So the one intercept. That one is very clear. X-intercept would be 6. A few more. Oh, that was the last one. All right. X-intercepts, Y-intercepts. I think a pretty straightforward concept. Sometimes you're looking at graphs. If it's not always clear cut, it can be a little dicey, but a lot of times it'll be very clear what the intercepts are.